Okay, now in the second part of this intro, now we have an inclined line over here. Okay, now suppose if this point is A and its coordinates are x1, comma y1, and here is a point B. This is x2, comma y2. Now, when we say that the distance AB is the square root of, this is x2 minus x1 whole square plus y2 minus y1 whole square. Now, is there anyone who can tell us that where do we get this formula from? This x2 minus x1 whole square plus y2 minus y1 whole square. Yes, Bacho? There is Merva, I can see this Madhya.
Pythagoras theorem.
Shafiq says we get this from the Pythagoras. How do we get the Pythagoras theorem involved here? Hmm?
If you connect B and A, if you like extend straight lines, a right angle triangle is formed.
Yeah, you are absolutely right. If I draw a line from here, maybe it goes to this side, and then I draw a line from here like this. And now I have a point. Let's say there is a point C over here. So, yes, Tahira. Tahira, can you tell what are going to be the coordinates of the point C? Please, brother, we have to be quick. Tahira. What are the coordinates of the point C? Okay, let me ask you. Just no, I'm asking from Tahira. Tahira, beta, look at this. Suppose you have a line over here. Let me. There is a line over here. Okay, and we are given that here is a point A, which is, let's say, 2.
Sir, her mic isn't working.
Tahira's mic is not working. Okay, this is
Yes.
okay. This is let's say this is 5, comma 12. Okay. Now suppose the question, you people have done many questions like this in your O levels. Okay. Now suppose we're given that there is a triangle ABC, and this triangle has x equal to 5 as its line of symmetry. So what are the coordinates of the point C? Please try that before you respond to me.
Someone's in the waiting. Can
Yeah,
you
Halima.
please answer?
Okay, someone is waiting. Let me enter that person quickly. Okay. Now, the question was that there's a triangle ABC, and we were given the coordinates of the two of its vertices, and we have to find the coordinates, the third vertex C, in such a way that x equal to 5 was its line of symmetry. Okay. So we have to draw the line of symmetry. You see x equal to the first thing you need to know is that this x equal to 5 has to be a vertical line. Okay, this is x equal to 5. So yeah, this is x equal to 5. And then the second thing is that this triangle has to be completed around this line of symmetry. So I'll be taking a horizontal line from here, approximately making this symmetrical about this line, this vertical line. So this is how I think we should have, this is where we can have the point C. So the first thing is you have to complete this triangle like this, okay? Now, again, using the concept of the vertical and the horizontal lines, if suppose this point is D over here, you can easily tell the coordinates of D. Yes? Should I ask from Alina? Alina, what are the coordinates of the point D, beta? Please tell us quickly. The coordinates of the point D. Yes, Alina? Alina.
Sir, 5, 2.
5, 2. Y5 to, okay, let me ask you
Sorry,
why.
five. No, sir, 5 5.
Yeah,
Sorry.
exactly. This is 5 5. Okay. Now this is 5 5 because this BD is a vertical line. Okay. So you go anywhere on this line BD, the X coordinate is always going to be 5. Okay. So therefore, D will have 5 as its X coordinate. And similarly, if you look at this um, AC, it's a horizontal line, and here this y coordinate is 5. So that means the y coordinate here will also be 5. Okay, so that is our first of all, you have to have this d as 5 5. Now what is this distance AD? So you will see that this 5 minus this 2, that is going to be 3. If this
3.
is 3 and there is a line of symmetry, this should also be 3. Okay, and then it's a turn of the point C over here. So we already know that the y coordinate is going to be 5 because it is a horizontal line, okay? And we have to think about this x coordinates. So this 2 plus 3 is 5, and then 5 plus 3 is 8. So that is how this point C is going to be 8. So guys, uh, I always suggest some friends for my students, that you should be friends with that guy, okay? So the two persons that I would like you to be friends with, you must send your friend requests immediately to these two people. These are, one is the horizontal line, the other is a vertical line, okay? If you have really very good terms with these horizontal vertical lines, then you can really be very good at mathematics, okay? Some, like not sometimes, many a times, the concept of the vertical line and the horizontal line, that helps us a lot while dealing with the complicated questions, okay? So you should be knowing, when you're, I mean, friends with someone and you are a very good friend, you're best friends. So you know each and everything about that person. So you must be friends with the horizontal and the vertical lines, okay? There are some more friends I'll be suggesting you, like isosceles triangles and the concept of similarity. If you are friends with these things, these small people, you believe me, a friend in need is a friend indeed. So these friends will help you a lot when you will be in trouble while solving complicated questions. Okay. So going back to uh, the previous sheet here, where we were trying to discover this distance formula. So in the same way, this BC is a vertical line. So you can say that here the x coordinate is going to be x2. Okay. And this AC is a horizontal line. Since here you have the y coordinate as y1, so here the y coordinate will also be y1, okay? So when you have determined the coordinates of this point C, now we can proceed. Now one thing before we proceed, that this, some of you, instead of writing this x2 and y2, you see, you can have x1, you can have x2, you can have x3, you must be knowing this notation. So there is a difference in this, and there is a difference in x squared and x cubed. You see, when you write x squared, the power is written right at the top over here. X cube is written like this. So don't confuse yourself. So basically, when we say x1, x2, x3, x4, these are different values that x is taking on a line, or maybe in a sequence, or like whatever, okay? Similarly, you can have y1, y2, y3. So please, again, this should not look to be something weird or very abnormal to you. Like when I say that what is the distance BC over here, so that is basically y2 minus y1. The difference between these two values of these y's over here, okay? Similarly, the distance AC can be written as x2 minus x1. And now, the people who are saying that the distance formula is basically derived from the distance formula, I mean, the Pythagoras theorem, so they were absolutely right. This is one of the sides of the right angle triangle. This is the other side. So this side is going to be the square root of this x2 minus x1 whole square. And this is y2 minus y1 whole square. Now, if you remember that this has been derived from the Pythagoras theorem, then you will never forget this plus sign between them, because there are many formulas in this coordinate geometry where, like, for example, if we write the gradient, you see this is the rise over this run. So this is going to be y2 minus y1 over x2 minus x1. Some of you are confused about this sign over here. And by mistake, you write a minus over here. So remember, in your Pythagoras theorem, there is always a plus between these two squares. So from there, you should remember this, that the distance formula has a plus between them. Okay. That was the introduction to the distance formula. Now from here, we